So let's talk again about what a confidence statement is and just the basic structure of these statements. So remember that a confidence statement will tell us how accurate our conclusions about the population are. And there are several things we want you to keep in mind about confidence statements. And some of these things we've already talked about. So of course, remember that when you write out a confidence statement, you are trying to draw a conclusion about what's going on in the population. So you're writing your statement about the population, not about the sample. You're using the sample to get your confidence interval, but your confidence statement's about the population. Our conclusion about the population is never going to be certain, so we can never say with 100% certainty what's going on in the population. And also we know that actually the bigger the confidence level, the wider the interval will be. So if you want to be very confident, you can be, but you have to realize that there's a downside to that. And the downside is that your margin of error will be larger, and that will lead to a larger or a wider interval. However, if you want to have a more narrow interval, one thing that you can do is you can increase your sample size, and that will lead to a more narrow interval. So let's go back to our beans example. So remember that earlier we had an example where we had 4 out of 25 beans that were red. Let's say now that we have a situation where 22 out of 100 beans are red. So I want to again find my sample proportion. That would be 22 over 100 or 0.22. If I want to find 1 minus p hat, that would be 1 minus 0.22 or 0.78. And again, I know I have a sample size of 100. So I'm writing these things down because I want to create a 95% confidence interval. So I'm going to use that formula, p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. And so I have 0.22. If I want to have 95% confidence, my z star value, remember from that table, would be 1.96. And then I'll plug in these other numbers that I figured out from my sample. And when I figure this all out in the end, what I end up with is an interval. I end up with 0.22 plus or minus approximately 0.04. So again, if you're doing this with me, you might get slightly different numbers if you've rounded in a different way, but as long as we're in the same ballpark, that's what matters. And this will give me 0.18 to 0.26. So I want you to compare that with the interval we had a little bit earlier. So when we had just 4 out of 25, so a smaller sample size, you might remember the interval was 0.02 to 0.30. So increasing our sample size is leading to a more narrow interval. So the range of values here with the larger sample size is smaller compared to this range with the smaller sample size. And if we took many, many samples of size 100, we'd expect there to be less variability among our sample statistics. And I hope you're thinking about why that's the case. Imagine that, each time we're taking a sample of 100, we're taking a bigger portion of the population. We hope that each sample statistic's getting closer and closer to that true population value since we have more of the population in our sample. And so if each of the sample statistics is getting closer and closer to what's actually going on in the population, and we looked at all of the sample statistics and a sampling distribution, we'd expect that distribution to have less variability than a distribution based on smaller samples, based on samples of size 25, for example. So going back to the example a little bit earlier, I showed you a picture. I asked you to indicate how old you think this man would be. And I want you to look back at your number, and I want you to think a little bit about how confident you are with your estimate of his age. So let's imagine, let's imagine you thought 40 was the age. How confident are you that you got that correct? And maybe you're really good at guessing ages or telling people's ages from a picture. Maybe you're right on. Now I want you to take that number and I want you to add and subtract 5 years. So again, if I had 40, I'd have 35 to 45. And now I want you to think of how confident you are that this new range of values you have actually includes the true age. Now let's imagine that we add even more. Let's add 10 years to the age. Now we have this range 30 to 50. How confident are you that this new range includes the age? I'm hoping that you're more confident about the larger range because, it's a big window here. There are lots of ages that are included between 30 and 50. So we hope that we, have a really good chance here of capturing the true age. So we might have more confidence in this particular interval. It's a wider interval. So it's hopefully has a better chance of getting that true population or that true value that we're looking for. But again, it's not giving us a lot of precision. So 30 to 50, we're not going to get a very precise answer as to how old this person is. The true age actually is 43. So if you got that, that's really great. And we can see, that falls in our different intervals here. But the point of this is that we can be really confident in an interval that's very wide, but that wide interval is not giving us a lot of precision. So is higher confidence always better? Is a higher confidence level always better? You might be looking at your options and you might be thinking, why don't I just always choose to be 99% confident? Because, that interval has a really good chance of capturing the true population parameter. That's correct. But with a larger level of confidence, so larger confidence level, comes a larger margin of error. So there's a trade-off here. You can be really confident, but you have to be satisfied then with the fact that you're going to have a wider interval and you're not going to have as much precision. What could you do to balance that out? Well, you could have a lot of confidence, but you could also try to get a large sample size. So as we increase sample size, or n, we decrease the margin of error. So you want a small margin of error and you still want to have a lot of confidence, try to increase your sample size to balance those things out. So a higher confidence level, is it better? Not necessarily. This is all a balancing act, and we have to figure out what's most important. Is it more important to be very, very confident, or is it more important to have some precision in our estimate? And if both are important, there are things you can try to do to still have a lot of confidence, but still have some precision. So I want to ask a couple questions here as we start to wrap up our portion of the lecture on proportions. And again, as always, I encourage you to kind of look at the options here, pause, come back, see if your answer matches mine. A Gallup poll asked 1,523 adults and 501 teens. So we have these two samples here. One is larger than the other. Whether they generally approved of legal gambling. The margin of error for a 95% confidence statement about teens would be what? So here are our options. So I won't read through all of those in the interests of time, but the basic thing to keep in mind is that the teen sample is smaller than the adult sample. The teen n, or sample size, is smaller. How does a small sample size affect the margin of error? So the smaller sample size would lead to a larger margin of error. So the margin of error for teens will be larger than that for adults because the teen sample is smaller. So A is the best answer here. A 95% confidence interval is 34% plus or minus 6%. A 90% interval based on the same sample would have what? Again, look through your options. I'm hoping that you're saying that B would be the answer. So here, the center would be the same. The center, remember, is going to be your sample statistic, what's in the middle of that interval. And if the sample's the same, we'd have the same statistic. The margin of error will be smaller because, remember, increasing your confidence level increases the margin of error. So decreasing the confidence level would decrease the margin of error. So we can't be as confident, but we're going to be a little bit more precise in our estimate. There's more of a chance we're going to be wrong, but we're going to have a more precise estimate. So think about it that way. So let's do one more quick example before we move into confidence intervals for means. So here's a new example. A German researcher studied kissing couples, so the individuals here would be couples, not one person, to see if they tended to lean their heads to the right. A total of 124 kissing couples, so n equals 124, were tested in a variety of settings. It was observed that 80 out of 124, or approximately 64.5%, turned their heads to the right while kissing. So 80 over 24 would be p hat. So here we're giving you the percentage. We want that to be actually in the form of a proportion. So we're going to have it in the form of a decimal. If you want to turn a percentage into a proportion, simply divide it by 100. And now we're going to use our, so we again want to do a 95% confidence interval. What do? We take p hat, 0.645. Plus or minus z star, which would be 1.96 because of the fact that we have 95% confidence. What do we multiply that by? 0.645. And then we multiply that by 1 minus 0.645, which is 0.355. And again, please check my work. I might make errors. I want you to help me spot them. Divided by 124. Okay, so I just kind of quickly want to make sure I got the right numbers here. Okay, let me pause a second and just check my calculation. Okay, so I double checked and I have everything right. So this would be 0.645 plus or minus. This whole thing together ends up being about 0.04. So again, please double check my work, make sure we did things correctly. This would end up giving us 0.605 to 0.649 approximately. So again, think about how you would write a confidence statement around this information. What I would say is I am 95% confident that between 60.5% to 64.9% of couples in the population tilt their heads to the right while kissing. So remember, we're creating an interval, we're writing a statement where we try to draw a conclusion about what's going on in the population. We have a certain level of confidence that this interval is going to include the true population parameter, in this case a population proportion. So I'm going to stop here. The next video, which I'll try to get through quickly, but we might need a couple more videos here. The next video will focus on confidence intervals for means or averages.